Hey everybody. So this is John Whitehead and it's 10:10 a.m. and we're supposed to be having class now, and I'm just now getting the class online um, for various reasons. But this will be open until Monday at 10 a.m. so you can enjoy your business statistics class anytime between now and our next class meeting period. So here we are during this week. We're going to take a look at a little bit of chapter 12, and then I'm going to have a problem set uh, ready for you to go um, hopefully by 11 o'clock today, um, today being Friday. So let me open up this PowerPoint. And on Wednesday we introduced simple regression analysis, and we talked about visual displays and correlation. We talked about what simple regression was, talked about some regression terminology, and I want to continue to pursue those three topics before we talk about the ordinary least squares formulas and tests for significance beginning Monday, and probably overall fit on Monday as well. So we talked about goals from this chapter. We talked about visual displays and scatter plots. There was the example that we looked at. So in Microsoft Excel, we worked through how to put a scatter plot together, and there's one with the problem set number 4, data, where we're plotting income against experience. We talked a bit about the correlation coefficient, the correlation formulas, and different ways that correlation can look in a visual display. We talked about the t-test, the critical value for a correlation coefficient, and a quick rule for determining if that correlation coefficient is statistically significant. So then we introduced simple regression and some regression terminology. The idea with simple regression is that you have one independent variable x and one dependent variable y. It's simple because there's only one explanatory variable on the right-hand side of this equation. And we worked through what the intercept and the slope look like algebraically, and then what they look like geometrically. Okay, and we also talked about the interpretation of the intercept and the slope. So a couple things about a model like this. Simple regression doesn't prove anything. A lot of people will estimate a regression model and think that because one variable is on the right-hand side, the independent variable, the x, that it is causing changes in the dependent variable. A lot of times that is true, that can be the case, but you have to have some good theory to tell you that that is actually going on. So an example from microeconomics is that we have some pretty good theory to tell us that a price change will cause a change in behavior. So we would regress the behavior change, changes in quantity demanded against a price change. And we can make some pretty good statements that the price change is causing the change in the behavior. You could just as easily regress a price change against a behavior change. And just because the behavior change is on the right-hand side doesn't mean that it is causing the price change. Okay, and in terms of prediction, we'll talk about how these regression models can be used to forecast changes in business activity or individual behavior. The idea is prediction should usually be done cautiously, and especially if the range of variation in your independent variable x is narrow relative to the prediction that you want to make. So if we're looking at if X is a price variable and we've observed price changes between $5 and $10, and we want to know what would happen if the price changed to $15, then you can make that kind of prediction with your regression model. But it could turn out to be inaccurate. Okay, for one reason it might be is because between a variation of $5 and $10 in the price, the relationship between X and behavior, Y, might be linear, might be estimated accurately as a linear model, but outside that observed range, it's nonlinear. So you might have diminishing returns to the price effect. You're not picking that up in the observed range. And so if you forecast beyond that range, then you might make a big mistake. Okay, so these are just two cautions that we're mentioning right now. When we start working with data, we'll see more about how those things can work. Okay, so I'm going to have problem set number 4 posted here for you. I want us to work with this human resources data. And here's just some simple and just the step-by-step instructions on how to get a scatter plot and how to estimate a regression line through those data. So this is step-by-step. Let me change this to numbers. There we go. Okay, so the first thing you do is highlight the data columns, and there's a trick to getting this correct. You need your dependent variable on the right, or you need to highlight it second, and we'll see how that works. Then click on Insert, then choose the scatter diagram, and a scatter plot should appear in your Excel spreadsheet. Okay, then if you click on the scatter plot points, the dots, and select the data, actually, that's not one of the steps. So here we go. If you click anywhere on the graph, and then click Chart Elements and choose Trend Line, then that is going to very quickly estimate an ordinary least squares regression line for you. Now, we haven't talked about what ordinary least squares is. We'll do that beginning Monday. But first, let's just think about this trend line, and we'll do some stuff with that. So then if you right-click the trend line for the functional form, or if you right-click the trend line, you can click a box and get the regression equation. You can also estimate different functional forms and do some forecast, but we're going to save that stuff for later. Okay, so here's what your scatter diagram and trend line might look like. So the data itself are these diamonds, and the trend line is the dark line that runs through these. The regression equation is y equals the slope times the independent variable plus the intercept. And the r squared, we'll talk about that guy later. Okay, so let's open up some data. Go back to As You Learn, and let's see, let's move that data up to this week. So I just want to label text. So Friday, October 23, no class. That's not true. Class is online today. Okay. Okay, and I'll have a link to this video underneath the online label there. And then I'll make problem set number 4 live as soon as I get the video ready. So let's download the problem set number 4 data. And there it is. This is the human resources data. We've got our employees' income, their work experience, and their schooling. Okay, so the first thing you need to do with these data is make sure your dependent variable, income, is to the right of your independent variables, experience and schooling. Okay, so I'm going to illustrate what we're going to do with these data and what the quiz and as you learn is going to look like with the experience variable, and then y'all can have at it with the schooling variable. Okay, so let's just highlight the experience and income columns, click insert, and then under charts click on the scatter diagram. And so you know you have the correct dependent variable if it shows up at the top of the chart. Okay, so let's say that you didn't watch this video. You went right to the quiz, and so you highlighted income and experience. You insert the scatter diagram, and experience is at the top. Okay, so work experience is on the vertical axis here, and income is on the horizontal axis. When you go to display your regression equation, it's going to be wrong. You're going to get wrong answers in the quiz. All right, so let's don't do that. Let's get rid of that guy. Okay, so the first thing you need to make sure you do is include income to the right of the dependent variable. Click on the scatter plot. Okay, so my little plus sign chart elements is popping up over here. You might need to click inside the box somewhere to get that to pop up. If you click on chart elements, so we have our axes labeled. We've got a chart title, which is income. We've got our grid lines, and we want a trend line. So there, as soon as you highlight it, it shows you the trend line, and that's the ordinary least squares regression line. I'm going to click that box so that it's in there. There's a little arrow to the right of trend line. I'm going to click it, and it's going to, let's see, trend line arrow, and you could change the functional form. There's exponential functional form, a linear forecast. That's where you can make predictions beyond the range of the data, and more options. I want to click more options. Okay, and there my big head is in the way, so I'm going to move this over a little bit. So down at the bottom, this is where, so the trend line options is where you can change functional form. So here you see an exponential function has a curve to it, logarithmic function has a curve to it, polynomial has two curves, power function has curves. These are non-linear functional forms. We're going to stick with the linear functional form. And over here you can make forecast, forward forecast, and backward forecast. We'll hold off on that for a while. What I want y'all to do is display the equation on the chart. And there it is, this little equation. I'm going to move it up to where there's a lot of white space so I can really see what's going on. Okay, so this equation is almost in the form that we've been talking about. It's got the dependent variable y on the left-hand side and the independent variable x on the right-hand side. We've been displaying our equations as y equals beta naught plus beta 1 times x, where beta naught is the intercept and beta 1 is the slope. And this equation just, see if I can do this, just reverses those two guys. So here's the slope, 0.521. It's a positive slope, and so the line is moving upwards as it goes from left to right. The intercept is about 63, and there you can see it on the vertical axis. So it intercepts the vertical axis just above the 60 line. Okay, so income is equal to, if there's no work experience, income equals $63,000. That's our starting pay on average at this business firm. And for each year of experience, income goes up by about $521. Okay, so there's questions that I want y'all to answer about a similar regression model. So let's see, here we are in the question bank, and let's look at problem set number 4, and I've got a bunch of questions. There's some of these I'm not going to ask, like we're not worried about the R squared right now, or sum of squared errors, or residual sum of squares, or explain sum of squares, residual sum of squares, and total sum of squares. That'll be on the next problem set. Right now I want you to to try to figure out what the intercept and the slope is. So here's a question. Estimate the simple regression model. Income equals B0 plus B1 times experience. The intercept parameter is 62.93. So submit and finish. And that's correct. Okay, I'm going to ask you a question about the slope. Estimate the simple regression model. The same one, the slope parameter is 0.52. Submit and finish, and that is correct. Okay. I also want you to be able to figure out what the sample size is for this regression model, and I'm going to add equation and add a question that asks you about interpretation of the regression model. And right now I'm thinking there's going to be 2 questions like that. I just changed my mind. We'll just have 1 question like that for these schooling questions. Okay, so that's it. It's about less than a 20-minute video for y'all to watch, a 20-minute presentation, and there's going to be a problem set to fill up the rest of today's class time. So if you went to the game last night, I hope you enjoyed it. Hope you have a good weekend.